This video file was recorded in Sabunji University during recitations for the CS204 Advanced Programming course as it was given in the spring semester of 2017.
Okay, let's start with the second class for today. Are there any questions about the debugging stuff? So you know what's compiling your code in debug mode and release mode, and why we need that. Now, there was something else that I want to ask you. Here, I'm defining. Okay, you remember this stuff, integer debug equals to 0, and then I'm using if debug is equal to 1, then I'm counting, I'm printing my variables to see their output, whether it's okay or not. What do you think? Should we use debug like this? Debug integer debug equals to 0, and then use if-else clauses as we have seen? Or should we use if defined, if not defined, this place here, this guy here? What do you think? Again, let's say I'm trying to debug my code and find errors and see whether the output is as I want it to be. That's why I define an integer which I call debug. If it's 0, I'm not debugging. If it's 1, I'm debugging, meaning I want to print. Now, let's say that I have variables called integer a and b only this time, and I'm printing them. I'm doing some processing stuff, and then I'm printing cout a and b. Okay, this should be enough. Now, after processing, do you think this is better to use if debug is equal to 1 than cout? Or this guy is better? Sharp if defined debug then I'm printing cout, basically the same stuff from here, and then I should put and if. Which one is better? They're doing the same thing. So if I want to switch to release mode, I just put this debug here to be not 1 but to be 0, and I'm not printing it. Or in order to remove this debug guy here, I just should switch to release mode. They're doing the same thing. And which one is better for you? Tell me why. Do you understand the question first? I'm trying to debug. And let's say I want to trace those variables a and b and see whether their output is correct. And I'm printing them like hundreds of times in my code. I can do it this way. If I'm debugging, if debug is 1, then I'm printing. Okay, again, I can do this using the debug compilation mode. If I've defined debug, then I'm printing that. If it's not defined, I'm not printing it. If this is 0, I'm not going to print it, okay? So which one is better, this one or this one? They're doing the same thing. And tell me why. Why it's better? The second one, you say. Yeah, you click once and change it, but here in the debug, you change only this debug value to 1 or 0 only once. And this is it. Does it compile to? Yes. It's going to work again. So basically that stuff that you do with clicking, you do it here with 0 and 1. So are they the same or not? You would prefer which one? This one? Yeah, this one, but why? Yeah, you forget. Okay. You forget where did you define this debug, okay? And the button there is more obvious, okay. But there is more important reason about this one. Which one is that? Pre-processing. Why? Because when you do it in release mode, you're not going to check this if it's true or not. It's going to be erased. And checking if it's true or not, let's say you check it 20, 30 times, 100 times, it takes time. Okay? So in order, if your application executes in, like, let's say 10 seconds, 5 seconds, but because of this checking, is it 0, 1, it adds 1 more second, it's waste of time and of the processor. Okay? But with pre-processing stuff, if the bug is not defined, if you do it in release mode, this is going to be erased. And you remember the translation unit? It's not going to be part of the translation unit. Okay, that's why this is better. It's a bit faster. Not too much, since checks if this is equal to 1 or not does not take a lot of time. Indeed. Looks like we don't have any question. Okay, if that's the case, I'm going to delete it. I'm going to run it and tell you something new about this piece of code. So we are running it now in a debug mode. And how do we know that it's in debug? If its debug is defined, we should get this message: a dice with blah 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 sites had been created. So let me run it. And we get this: a dice with 6 sides has been created, because it's in debug mode. If I do it in release mode, you see this is not going to be printed. We don't get the message that previously got. And if we even get zeros, like we got zeros 2 times when rolling the dice, we don't have any mistake, because this is the release mode. Another way, I want to complicate your lives. Even if you're working in debug mode, you can add something like define no debug, and now even if you run the code, you won't see the mistakes, but the assert mistakes. Okay? So the debug variable is defined, but because of that no debug also, the assert is not working, as if it's released in release mode, not in debug mode. Maybe this might be too complicated for you, but I just wanted to know, to show it to you. All right. Now let's go to a new topic, which are called pointers. It's enough about debugging. Do you want me to talk more about debugging or no? No. Something else also. When you create a project, let's say this guy here, in debug, and when you create it in debug mode, you get this. When you compile it in debug mode, you have the debug folder. If you compile it in release mode also, you have the release folder. Let's see what we have inside. We have random generator object, main object. You see, buggy dice object. All the CPPs are created in one object, and those are separate entities. So the compiler, after pre-processing, the compiler creates objects, but they're separated. They don't interwork with each other. In order to work with each other, something which is called linker occurs, and it's like a puzzle, you know. The random generator helps for the main this part. Buggy dice is useful for this part, and we have the executable file in the end, okay? But I don't want to bother you more with that stuff. Now let's go with something else, which are called pointers. Have you heard about pointers? Yes or no? What are pointers? You have seen, did we cover pointers in CS201, Introduction to Computing? No, but we did references. And you know what a reference is? Basically, references are another name for the same variable, okay? Like aliases. But what are pointers? Let me tell you very briefly what are they. When I define an integer, let's say a equals to 5, automatically a piece of memory will be reserved in the RAM memory from the compiler. It will be of integer type. Its name is going to be a, and its value is going to be 5. Okay? Just like when your baby is created, you give the baby a new name, but that baby should live in a place, in an address. Okay? Well, those variables have memories, have their homes, but they have memories. Let's say the addresses. Let's say the address of this guy is, I'm making the number, 91. This is the address. All of the boxes that we have used up until now have addresses, just like you have your addresses, okay? And variables have their addresses. If I say something like this, integer star ptr, when you see this star, you should know that we are dealing with pointers. And pointers point to the address, not to the value. So A is 5. A is in the box 91. But this star ptr, I'll make it to point to the address of A. And you have seen this sign before. This is the ampersand. Okay? This is for the address. So if this is A, ampersand A is 91. That's why when you send your variables as references, you are sending the address, and to that address a new name is assigned. But this is something similar, but not exactly the same. So ptr, with this command here, I've created a new variable, but this variable is not an integer. This is a pointer to integer. It's not the same. Its name is ptr, not star ptr. This star is just to tell us that this is a pointer to an integer, but the name is ptr. With this command here, I'm saying that the value of this box here is 91. And basically this pointer is pointing here. Of course, this has its own address as well. It might be like 120. Everything that is allocated to memory has its own address. Like every house in Istanbul or the world has its own address. Every piece of memory has its own address. Now, can we access the value of a certain integer through the pointers? Yes. How can I do it? If I say this guy, star ptr, ptr is 91, but star ptr is 5. Okay? And do not mix it with this star here. This star here is when we declare a variable. We tell that it's a pointer. But after declaration, we have it in the memory, and I want to access the value to which this ptr is pointing, and I use this stuff here, star ptr. And if I say star ptr is equal to 10, then I go, okay, this is ptr. Value of ptr is 91, and the value to which ptr points is this one. This is going to be 10. Is this clear? Okay? So remember this stuff. You're going to need it for the 2 examples we are going to go over in this class. Is this hard? No. If this is not hard, let me do it harder. If you want to become more complicated, and we will see why we're not going to need this, we are going to define a pointer of a pointer. An integer is not the same as the pointer, and the pointer to a pointer is not the same as a pointer. And let's call it ptr. I'm making the name. So when I did this guy here, I've reserved another memory which is called ptr, and this is a pointer to a pointer. I want to assign a value to this ptr, so I'm doing something like this. This is the address of the ptr. Address of the ptr is 120, so I have here 120. Basically, this pointer now is pointing to another pointer. If I want to change the address of this guy, I can use star ptr is equal to something. But what do you think? Using the value of this pointer, can I access this guy? Yes or no? Yes? How do I do that? First I have, yeah, very nice. I have to access this guy. How do I access this guy? Star ptr is 91. Another star. So with this guy, I'm in 91. With this star again, where am I? I'm here. And if I say that that guy is 20, then I'm going to change it in 20. Is this clear? Is this hard? Yes?
You give a value to the pointer, right?
Yeah, and the value of the pointer is the address of PTR. The address is...
When you start pointer, the address changes the pointer changes the address value. Like,
I didn't change.
Can you explain how the value is changing?
Okay. So up until here it's okay. Let's go like this. We have A is 5. The address of A is 91. We define a new pointer. It has no value. So PTR, no value inside. When I say the value of this pointer to an integer is the address of A. This is the address. Address of A is 91. And PTR is the address of A. I have here 91. Is this your question?
Yeah, like 91 is different from 5.
Yes, of course. 91 points here, and the value of 91 is 5. Okay. This guy has also its address. So I'm pointing here now. Then I'm defining another pointer of a pointer. PTR. I'm saying it's a pointer of a pointer. I know it because I have star. And this type is not the same, like integer, character, blah, blah, blah. We have another type which is called pointer. The pointer of a pointer is another type. They're not the same. Now I want to put the address of the pointer to a pointer here. How I do it? In this manner. So this would be 120, meaning this guy is pointing here. If I want to change this guy from this guy, okay, the integer from the pointer, then I use star ptr, I'll go here. So I access this value. Another star, I go here, I change it. If I made it 20, this is going to be 20. Is this clear? Is this hard? Yes or no? No? Do you want to make it harder? Okay, let me go crazy now. We have a pointer of a pointer also. It's doable, but I don't think that you'll need more than a pointer of a pointer. Okay, 2 levels. Now you might say, why do we need this stuff? Well, we need this stuff to make you suffer. Okay? This is one reason. The second reason is the following. Let's say that I have the swap function. I have an integer A, an integer B, and this is how it works. I defined another integer, temp, it's equal to A. I want to swap values of A and B. B is equal to temp, and A, am I doing it right? Temp is equal to A is equal to B, and B is equal to temp. Now let's see what this guy is doing. I have an A here, let's say it's 5. I have a B here, this is 3. Those are the parameters of the function. I want to swap their values. I defined another variable, temp, to help me. And I want to switch the values of A and B. And I say this temp is equal to A. So temp is 5. Then I'm saying A is equal to B. So this guy is going to be how much? 3. and I'm saying b is equal to temp. So b is going to be 5. Did I change the values? Yes. But what if I call this function from main? In main, I have an integer a5, b3, and I call swap a and b. Am I going to swap them or not? What do you think? By reference. Otherwise, if I don't pass them by reference, I have here AB. This is A. It's 5. This is B. It's 3. So remember, because I've seen from previous years, this should be clear from CS204, but I've seen from previous years that some students don't know what happens when you call the function. When you call this function swap, yes, you have here A and B, but this A and this A are not the same. We are creating a copy, which is called A, and the value of A is 5. And we are creating a copy of B, and its value is 3. Okay? This A and this A, although they have the same name and the same value, are not the same. They're different. Okay? But it's like having twins with the same name but in different places. They're not the same person. So here, if I do the swap, so this A becomes 3, this B becomes 5. And when I finish the program, the function, when it finishes, everything that is associated with it is going to be erased. So when I go back here, they're not swapped. Of course, if I send them as a reference, I don't create new copies here. I do the changes here. Now, why I need the pointers? Well, I need the pointers since I'm expecting here a pointer that which points to A, another pointer that points to B. And I'm sending here the address of A and address of B. Let's say the address of A is 50. I'm making the numbers. They're binary, by the way. The address of B is 60. So when I call this function, this is what happens. I have star here, star here, star here, and star here. I have a pointer to an integer called A, pointer to an integer called B. So I have A, which is a pointer, remember, and I have B, and this B is also a pointer. I passed the values. So here I have 50, and here I have 60. Okay? Here I create a temporary integer, which is called temp. This is not a pointer. And I said temp is equal to star A. What does that mean? Star A, you remember from here? So if this is 50, star A, so 50 points here, 60 points here. When I say star A, that means the value to which A points, which is 5. So temp is going to be 5. Then I say, okay, star A is equal to star B, meaning that the value to which A points is equal to the value to which B points. That means that A becomes 3 now, okay? So this is 3, A is the value to which B points. But remember, these are pointers, these are integers. These are pointers to integers. Now I go and I say the value to which B points, this is B, is equal to temp. Temp is 5. I have 5 here. The function is finished. Everything associated with the function is going to be erased, so I don't have these guys anymore. And did A and B switch the values? Yes. Okay? So this is why we need pointers. You might say, okay, we can do it with references. You are correct. References are a better way of doing things. Okay? Because with references you don't have to reserve another memory chunk for the pointers. And some languages like Java don't use pointers because references are going to do it for you. But since we are studying C++ here, we should cover pointers also. If this is all clear, then let's go with the first example for today, which is called pointerExample. So please copy paste your code from pointerExample. This is pointer point CPP. Just copy this guy and paste it. Let me create a new project, okay? You might be confused. General, empty, okay. I'm going to, we don't need those folders anymore. Paste it here and just edit. So this is our example. Let me put system pause. Of course, you know that you shouldn't use it for your homeworks. Instead, scene, ignore, seeing, get should be sufficient, okay? But I'm used with pause and I'm doing that. As a male and as a lazy programmer, I want to do things as fast as possible. This is our output of the program. This is what we get. So we show here the values and the address, okay? Of the pointers. Let me enlarge the font. You see the addresses are given like this. So don't expect something like 4. Levent, Aydınla Mahallesi, numara 14. You don't expect something like that, okay? Because addresses are expressed in binary form for the memories. And we have the addresses and the values of those addresses. Now let's see how it works. I'm going to use breakpoints here because I want to stop the program at each step and see what has happened there. So this is what we got here. Let's see how we did get it. Let's go line by line. It should be an easy one. If you understood this part here, it should be rather easy. I'm defining a pointer. How do I know that it's a pointer? Because I have this star to an integer, and this is not an integer, this is a pointer to integer called PINT. So I have PINT here, and it's empty. I go to new line and I say P is equal to new INT. Remember this command. When I say new, what I'm doing is the following. I'm going to create this new, creates new integer. This new integer has its address. Let's say its address is 100. And since I'm saying that, so new integer creates new integer without any value. And when I say PINT is equal to this new integer, meaning that the pointer to this integer points to the address, meaning that, not to the address, but to the integer. The value of this pointer is 100, and it points to this integer. The value of this guy is empty for the time being. I go to this line and I say star PINT is equal to 1. What I'm doing here, the value to which PINT is pointing is 1. So we'll have 1 here. Now, I'm printing address PINT shows blah blah blah. Now I'm printing this address. So I said 100, but its value is not 100. It's, in this case, A53C18. Let me write it to be more concrete. It's A5, we skip those 2 zeros in the beginning. A53C18. A53C18. And this guy points here. The content at the address, at this address, is 1. And how do I print that? So here, you see I'm printing PINT, the value of PINT. And the value of PINT is this one here. A5 3C1 3C18. When I print this guy, I have this output. And afterwards I say the content of the address is, now I have star PINT, star, the value to which this address is pointing is 1. That's why I have 1. Okay, now we go with the next line. Yeah?
We not need to put ampersand sign to take the address of the point.
You can do it this way also. But if you have an already existing integer, in order to take its address, you use that with the ampersand. Okay? But here you don't have the integer. You create an integer which is empty. Now later on you put a value to that integer. You can do it that way also. This is another way of doing things. Now, let me press continue. I have this output. I've created a new pointer to an integer called PINT2. So this is PINT2. Basically, I have merged those two lines and put them to one. A new line. So with this new command, I have an integer. The value of this guy is A58408. A58408. 8408. And the address of this guy is A58408. And it's pointing here. This is done with one line. Then I say the value of PINT2 is equal to 2. So star, the value to which this pointer is pointing is 2. Then I print the pointer, and I print the value to which the pointer is pointing, so I get this output here. Let's go with the next break. Yes? Yes, this is another PIN2, this is PIN2 too. The addresses are not the same. They're different, of course. They're similar to each other, you see, and there's a reason why. We will see why. Because we will see in the next example why.
How does it define the address? Like random?
Not really random. But it's a very complicated issue. You'll do it in this operating system course. And even not in the operating system, much more advanced than that. Okay? You don't have to care about that. You can assume they are random for now, which is not the case, by the way. We go here now. In this line, what do we do is the following. We define my integer, and my integer has a value of 3. This is not a pointer, this is a normal integer. Then I'm saying that the value of PIN2 is the address, so your question, of my int. The address of my int is, let me check it, A533C18. No. No, I'm sorry. We are doing this part here. I'm sorry. So I'm doing this stuff now. PINT2 is equal to PINT. Meaning that this guy is equal to this guy. So it's A533C18. And it's not pointing here anymore. Both of the pointers are pointing to this guy. This guy has no pointer, okay? I'm printing this stuff, and I'm saying that address PIN2 shows blah, 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 and its value is this one. So what's the address, what's the value of PINT2? It's A533C18. Let me check it whether it's the case. Yes, it's A533C18, and it's pointing to the value of it is 1. Okay, it's pointing to a block with value 1. Now we are here at this part, my integer is equal to 3. What do we have here? We define an integer, which is called normal integer, my integer, and its value is 3. So my int is equal to 3. Then we do this stuff here. Integer 2 points to the address of my int. We won't have this guy anymore. But here we will have the address of my int. It's 3, it's like this. Its value is 83. The address of my integer is 83 FBA8. FBA8. So the value of this integer is the address of that one, which is 83 FBA8. And I'm pointing here. And I print the content, and what's the content of this guy? It's 3. That's why we print that the content at the address is 3. This is pointing here, and the content of that address is 3. And I've printed 3. I can put it here. And finally, we have this guy here. I hope I don't have to write. But should I write it? Let me do it. So I have what? My int 2, and its value is 4. I have 4 here. Then I'm saying that this is interesting. The value to which pint2 is pointing is equal to my int2. So the value of pint2 is this one, 3, and it is equal to this one. So this 3 is going to be basically 4. And then I'm printing the value of pint2, which is 4. I'm printing the address, which is the old address, A3FBA8. The content of the address is again 4. Okay, the content of that address is 4. Any questions?
So you said the value of my int is 4, but isn't the start int2's value changing 4?
If I say A is basically the value to which the second pointer points is being changed. So the second pointer, pi star pint2, so this is pint2, star is this one. And I'm saying this one is equal to this one. That's why I say its value to there, okay? When I say A is equal to 5, 5 does not become A. A becomes 5. Question? No questions. If this is clear, very nice. We have like 10 to 15 more minutes. I can erase it. I hope you understood the logic behind the pointers. Now let's go and see how this stuff works with arrays. One of your friends, it was you, asked how are those addresses assigned. Well, there's a logic behind it. Now let's go and do something interesting. Integers. How many bits do integers have? You remember? An integer, how many bits does it have? It has 32 bits. Yeah, I told it so that's why I don't say yes. You didn't know that. I'm joking. It's 32 bits, meaning 4 bytes. The memory, the RAM memory, as the compiler sees it, is something like this. It's a kind of continuous tape divided into slots of 8 bits. So I have 8 bits. And here I have 1, 0, 1, blah, blah, 8 bits. Here I have also 0, 1, 0, 1, 1, and so on. Okay? In order to represent one integer of 32 bits, how many lines do I need? How many slots? 4. That's why it's 4 bytes. This is 1 byte. So this is one integer. All of those have their address. Okay? Let's say the address of this guy is 100. Of this guy is 101. Of this guy is 102. Of this guy is 103. And we have bits here, zeros and 1. This part here represents one integer. Okay? It starts from 100 up to 103. Let's say that this is a vector. We have assigned a vector. This is index 0. We have one integer here. The same applies for the next 4 slots. So 1, 2, 3, 4. We have here 104. These are the addresses. 105, 106, 107. Okay? This is index number 1. I'm continuing like this, and we have bits here, of course. 32 bits, 32 bits. If I go to index number, let's say 5. So this is index number 5. What's the address here? What do you think? What it should be? So, 104. Here we have 108 for index 2, 112 for index 3, 116 for index 4, 120 for index 5. Okay? And we have bits here. 4 slots, 4 bytes. Then we continue. Now tell me, what is the start address for index 10 of the array? So 120 is 5. 124 is 6. 128, 7. 132, 8. 136, 9. 140 is what? Is index number 10. Now, when I say 140 minus 120, we will get 20. Okay? But if I assign a pointer, let's say PTR, and the value of PTR is 120, PTR1, and if I assign another pointer to this index, PTR2, meaning that its value is 140, it points here. This PTR points here. I'm not going to draw the arrows. And those are pointers. That's why I'm going to write this star here. If I say PTR2 minus PTR1, like this, what do you think? What kind of a value I'm going to have? Is that going to be 20 really? So PTR1 is 120, it points here. PTR2 is 140. The ordinary arithmetic, mathematics, says that there's difference of 20 slots, 20 bytes. And it is the case. But since we're dealing with pointers, if I say this guy minus this guy, what am I going to have? What do you think? Or, if I'm pointing to a pointer, I can use if I have an integer and its value is 5, and its name is a, if I say a++, it's going to be how much? I have a, its value is 5, and I say a++, 6. With pointers, if I point to 100, let's say, and if I say pointer++, what's going to be its value? 110? No, it will be 104. Because it goes to the next pointer, to the next integer. Okay, this is one integer. When I increment it to point to the next integer, it points to the next integer is here. It's not here. Another incrementation, it goes here, okay? So if I say pointer 2 minus pointer 1, what's the value? How many elements are between 10 and 5? It's 5. Okay. If you understood this, you understood the next example that we are going to cover. The only difference is that this is for integers. We will have also, I think, short. And short have 16 bits, meaning it's 2 bytes. So if I have the memory like this, in 100 and 101, I have the bits here. And the first index element is here. So this is 0. What is going to be the fifth one? Index number 5 of the vector of the array. Come on, tell me. 110. Because short numbers, the type short uses 2 bits. It's going to be 110. And we have bytes here. Then I continue. What is going to be the value of the 10th index? 120. We have bits here. Those are integers. Again, those pointers are integer pointers. If I say I have, let's say, short pointers, short pointer 1 and short pointer 2. Short pointer 1 points to 110, let's say, and short pointer 2 points to 120. What's the difference between those two? Short pointer 2 minus short pointer 1. What's their difference? But why here it wasn't 10? It's 5. Because between 5 and 10, we have 5 elements, okay? So this is our next example. Of course, we have another array which is of booleans, and booleans use only 1 byte, which is easier, okay? Now, let's go. So remove this guy. From the folder, there is the last example called pointerExample. Just copy paste it to the solution folder, add it, and I'm going to run it now and see the output. I have 5, 5, 5. What I'm doing is basically this one. Let me just... I'm defining an integer array of 100 elements. And I'm defining pointers, which points to the 5th element and to the 10th element. I'm taking the address of the 5th element and of the 10th element. And I'm printing them. Basically, it's like printing 140 and 120. But when I take their difference, I have 5. If you don't trust me, just let me show it to you here. So I'm running this part of code, and this is what I get. Now let's use the calculator, and let's see those values in the hexadecimal form. So this is E6FB5C minus, I'm subtracting it from this guy, minus E6FB48. This is 14 in hexadecimal, but in decimal it's 20. And you remember here, the difference is 20 between them. Okay? But when I print the difference as pointers, it's going to be 5. Okay? The same applies for short. Again, I define another short array of 100 elements. I take the address of the 5th and the 10th and put it to those two pointers to short. If you don't trust me, again, check at your home. The difference between those two guys is going to be, how much? 10. Okay? But the difference in terms of pointer arithmetic is going to be 5. And in the end, I have booleans. Their difference is going to be 5, since booleans reuse 1 byte. And their pointers are going to be 5. Their difference is going to be 5. Did you understand this example? Be honest. How many of you understood it? All of you. Very nice. If you have questions about the homework, you can mail me or come to my office hours next week. Okay? This is it. Class dismissed. See you next week. Thank you.